Okay, we are going to prove that the inverse tangent of x plus the inverse tangent of 1 over x equals pi over 2 when x is greater than 0, and that it equals negative pi over 2 when x is less than 0. And the way we're going to do this is using an integral. So first, let's consider the case where x is greater than 0. Consider the integral from x to infinity of 1 over t squared plus 1 dt. We know that this equals the inverse tangent of t evaluated at infinity and x. The inverse tangent of infinity is just pi over 2, and then we have minus the inverse tangent of x. Now that's one way that we can evaluate this integral. But another way that we can do it is by multiplying the top and bottom by 1 over t squared. So if we multiply by 1 over t squared on the top and bottom, what we get is, on the top, 1 over t squared, and then on the bottom, 1 over t squared times t squared gives us 1, and then 1 times 1 over t squared is 1 over t squared. What I'm going to do now is, instead of writing 1 over t squared like this, I'm going to write it as 1 over t in parentheses and then squared. And what we see now is that we have a 1 over t in the denominator. And when we differentiate 1 over t, we get negative 1 over t squared, which is similar to what we have on the top. So what I'm going to do is write this positive 1 over t squared as negative 1 over t squared. And from here, we can do a substitution with u equals 1 over t and du equals negative 1 over t squared dt. We can plug this into our integral. On the lower bound, we plug in x here and get 1 over x. And then on the top, 1 over infinity is just 0. And then here we have negative, and then this negative 1 over t squared dt is du. And then on the bottom, 1 plus, this is u squared. And again, we can evaluate this as the inverse tangent of u at 0 and 1 over x, this time with a negative in front. Now when we do the inverse tangent of 0, we just get 0. And then we have minus negative inverse tangent of 1 over x, which is just the inverse tangent of 1 over x. So we've evaluated this integral in two different ways and gotten two different answers. But because we started with the same integral, we know that our results have to be equal. And in this case, remember that it's a definite integral. It has a lower and an upper bound, which means that we don't have a plus c in this case. So these two things actually have to be exactly the same. So this is telling us that pi over 2 minus the inverse tangent of x equals the inverse tangent of 1 over x. Or equivalently, the inverse tangent of x plus the inverse tangent of 1 over x equals pi over 2. So that is our first case. So now we're going to consider the second case when x is less than 0. And to do this, we are again going to use the same integral that we did before. So let's start out with the integral from x to infinity of 1 over t squared plus 1 dt. From the work we did last time, we know that this is pi over 2 minus the inverse tangent of x. And because we didn't do any substitution to get this answer, we know it's still legitimate when x is less than 0. Now let's look at what happens when we do the substitution that we did before. So we have 1 over t squared plus 1 dt, and we start out by multiplying the top and bottom by 1 over t squared. What we get here is 1 over t squared divided by t squared times 1 over t squared is 1, and then we have 1 over t in parentheses squared. Now from here, what we did last time was substitute u is equal to 1 over t. But we have a problem now because x is less than 0 this time, which means that we're taking an integral from a negative number through 0 up to infinity. So if we substitute 1 over t, somewhere in there we're going to end up with 1 over 0, which we don't want because it's going to mess up our answer. So what we need to do is split this integral into two parts, the negative part and the positive part. So this is going to be equal to the integral from x to 0, because x is negative, of 1 over t squared divided by 1 plus 1 over t squared, and then plus the integral from 0 to infinity of 1 over t squared over 1 plus 1 over t squared. From here we can do our substitution. So in both cases we're going to have u equal 1 over t, and then du equals negative 1 over t squared dt. And we'll use the same trick we did before where we have negative 1 over t squared. So what this is going to give us, for the first integral we have, again on the bottom, 1 over x. This time for the 0. Remember that x is negative, so this is going from a negative number up towards 0. So if we wrote this using the correct improper integral notation, we would get a limit where we're approaching 0 from the left. So this is actually going to be a really small negative number. And if we put 1 divided by a really small negative number, that's going to give us negative infinity. And then on the inside we again have here negative du over 1 plus u squared. And then if we do the same thing here, this time we have 0 from the right because we're going from 0 to infinity. So this is going to be 1 over a really small positive number, which gives us positive infinity, and then 1 over infinity is 0. We have negative du over u squared plus 1. Now when we evaluate these, we're going to get negative tangent inverse of u at negative infinity and 1 over x, plus negative tangent inverse of u at 0 and infinity. So when we go through each of these, what we're going to get, first on this one, the inverse tangent of negative infinity is negative pi over 2. And then we have minus negative inverse tangent of 1 over x, plus, for the second one, negative inverse tangent of 0 is 0. So we just have minus the negative inverse tangent of infinity, which is pi over 2. So we have negative pi over 2 is positive pi over 2, and then negative pi over 2 is positive pi over 2. So if we add those, we get pi, and then we have minus negative tangent inverse of 1 over x, so we get plus tangent inverse of 1 over x. So this time, notice we get an extra factor of pi when we split up this integral. So we again know that this result is going to be equal to that result because we started with the same integral. So what this gives us is pi over 2 minus the inverse tangent of x equals pi plus the inverse tangent of 1 over x, which means the inverse tangent of x plus the inverse tangent of 1 over x. If we think about bringing this to the right side and then subtracting pi, we're going to get negative pi over 2. That is our second answer. So once again, using these integrals, we've proven that tangent inverse of x plus tangent inverse of 1 over x is pi over 2 when x is greater than 0, and it's negative pi over 2 when x is less than 0.